Hello everybody, this video today will be covering IUPAC nomenclature. You will learn how to get a molecule like the one in front of you and be able to name it, as well as be given a name and turn it into a compound. Let's get started. Off the bat, you want to notice what molecule, where are you going to start. For example, when you're naming, the very first step is, hey, I could start here, 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 and here. Well, I need to find the longest carbon chain. That's the very first step. So let me just write that here. Longest carbon chain. Let me just start off with the first response. The first response would be always to go for the middle chain for many students. So seven. Well, I could still start on the top corner. Just by looking at it, my guess would be that the top corner would be a longer, would yield me the longer chain. So and it does. Well, you must be asking, what about this corner right here? Can't you start numbering it from here to here? Yes, you can. If you do start numbering it from here to here, it won't change anything. It will just make the other chain the substituent. You will still get the same name. So both of these starting places are good to start. Let me just clear the board for you guys. That should be good. So, like I said, I will start from here, just because it yields me the longest carbon chain, and the substituent number is about the same. I have the lowest number of substituents. You want to always ask yourself, there's only 3 rules that you have to memorize, and from there expand on. First rule, like I said, was to find the longest carbon chain. This is the abbreviation for that I'm going to be using today. And the second rule is to get the lowest carbon count for substituents. Count for substituents. The third rule is, if you have the same amount carbon count for both of the for either side of the chain, then you will alphabetize them. And this is in order to find the alphabetize. My vocabulary here. Excuse me, it's late at night today. You will have to alphabetize them. Jot that down real fast and I'll erase it. Throughout this video, these rules are crucial in determining the longest carbon chain when it comes to IUPAC. Off the bat, I noticed that the carbon chain is 8 carbons long. If it's 8 carbons long, then that's an octane. So the longest carbon chain being octane. Well, now I have to find the substituents. There's a substituent on carbon 3, and there's another substituent on carbon 4. What type of substituent this is? Well, there's 2 carbons off of it. So for your substituents, you're going to write, all your substituents are going to end with YL. So instead of this being ethane, this will be ethyl. But since this is the longest single carbon chain, this will not be octyl because it's not a substituent, but octane. Cool. And I have 4. Let me just do 3. So 3 ethyl, and then this is 4 ethyl. Automatically, I can now do the IUPAC nomenclature for this. I notice that there are 2 ethyl groups here, and only 2 substituents. So I'm able to write 3, 4 diethyl octane. As you notice that the longest carbon chain is right here, and diethyl means two ethyl groups at 3 and 4 substituents. You can also check that work by looking at it. You can be like, okay, my longest chain was octane, check. I have two ethyl groups branching off at 3 and 4. Yes, I do. Perfect. Let's move on. I want you guys to try this problem on your own. It looks like a beast, but trust me, it will test your knowledge on these three rules that I presented earlier. Let me just clear the board. No, I think that's good. So, okay. Hopefully you guys pause the video and try to do it yourself. Automatically, I can start numbering this right here, right here, right here, right here. These are the possible places I can start numbering this problem. My question is, where should I start? Should I start numbering this from this chain here, from this chain here, or this chain? Well, let's give it a shot. Off the bat, I already have a generalized idea that I should start, where I should start numbering. But for you guys, I'm going to start off with the middle chain. I get a 7 carbon chain here, and if I start at the way bottom, I get, let me do this in another color real fast. That's a highlighter. It's fine. Think of that as a happy little accident. There you go. 4, 5, 6, 7, 8. 8 is already a longer chain. That eliminates the possibility. That eliminates this as a possibility. That is not my longest carbon chain. Well, what if I go up from here? Darker shade of green. So if I go 7, 8, 9, 10. Wow, this gives me a 10 carbon chain. This eliminates this being a possibility. So that's not a possibility either. Automatically, you can easily infer that this is not a good entry place. Now, if I start from here, if I start from this carbon right here, at the very bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, no, 8, 9, 10. I get 10 carbons. Automatically, I am tied from, starting from either here, starting here, and starting here. These are my tie locations. Let me just clear this board up so you guys can see that. Right, so now that I have my starting locations, my 3 starting locations, I look at the third rule. If you guys remember, the third rule was alphabetical order. Because, well, I need the lowest... I'm jumping ahead of myself again, I'm sorry. The second rule states that you need to have the substituent with the lowest carbon count. The lowest carbon count substituent in this case will be between these two, because I instantly get a substituent at 2 and 2. This one I instantly get it at, if I started counting here, I would get it at 4, making this one a no-go, because again I would get it if I started numbering it here. I would get the substituent at 5. I don't want that. I'd rather have it at 2 or 2 than have it at a 5. This easily leaves me with 2 choices. This easily lets me identify my longest carbon chain, which is decane. I'll write out all the abbreviations for you, like which one's methane, ethane, like how many carbons you need for that later in the video. Automatically, now that I'm set with 2 single carbon chains, let me clear this out for you guys. So my longest carbon chain was a decane, and it's between these 2 substituents. And both of them branch off at 2. But notice it right here. Notice this real fast. You're branching off here twice compared to here. You're branching off only once. So my first point of difference gives me this as the smallest substituent. And you will see that I use the word first point of difference. In organic chemistry, usually you can come up with a fast solution, with a fast answer through your first point of difference. This is a natural trend that you can see on exams. It's not always the case, but mostly it is. Now if I start numbering this, carbon, ten, perfect. I want to see my substituents. Where do I have my substituents? Let me highlight them for you. I have 2 methyls. I'll give all the methyls a green. And I'll give my ethyls a lovely orange color. There you go. And I have a top butyl. Right? 4 carbons makes that a butyl. Automatically, I know that the longest chain, again, is a decane, because there's 10 carbons. If I would do the IUPAC for this, for you guys, instead of writing the IUPAC automatically, I will simplify it. I will write out how each substituent looks like. If you guys know how to do this, then feel free to fast forward or skip part of the video to me just giving you guys the answer. Yeah. So this is the methyl. And there's another methyl. Picture that's 2-2- methyl. There's on carbon 5, there's an ethyl. On carbon 5, there's a butyl. Carbon 7, there's a methyl. And on carbon 7, there's an ethyl. And on carbon 9, there's a methyl. Guys, got that? Sorry for my sloppy handwriting. Once I've gotten my substituents, now I need to get all of them. Combine all my methyls, combine all of my ethyls, and, well, I don't need to combine my butyls in this case. So, again, I highlighted all of them so it's easier. Off the bat, I do notice that butyl is shorter in the alphabetically butyl is the shortest. But instead of going into nomenclature, I want to make sure I give you guys like a guide, like step at a step time. When you get good at this, trust me, you can instantly skip a couple of these steps through practice. So I notice I have a 2-methyl, a 7-methyl, and a 9-methyl. This gives me 2, 2, 7, 9 tetra. Excuse me right here, let me just. Tetra methyl. I ran out of room here, so this is very unprofessional, but as you can see, this is what it yields me. And I have 2 ethyls, like I said. So I have a 5-ethyl and I have a 7-ethyl. This will be 5,7 diethyl. And now I have everything to name. I have, let me highlight them. Let me highlight the important parts of the name. Not the best color. Let me pick another. What's a good color? Not blue. Gray. Gray works. So I have this, this, and this. You guys can check. These are all my substituents for this molecule. Also, my longest carbon chain. Let me write that down for you guys. I've mentioned it enough in this video as decane. You got it? Now I'm going to connect all of these to my IUPAC. Just highlighting this here so you guys can see how I get my answer. So butyl, because that's the shortest, then comes 5,7-diethyl, dot dash here, this case point example, I'll just erase these, right? So I could just give myself a bit more wiggle room, right? Dash tetramethyl decane. That's the name of this molecule. So the overall name of this molecule is this. Right? Let's move on. Name the following compounds using the IUPAC system of nomenclature. Same thing. Off the bat, this place has way more places to start, but there should be one corner that's really calling you out here. That's saying I am the longest carbon chain. Again, pause this video, give it a try. I'm pretty sure you guys could rock it if you got the first one right. And if you didn't, well, another practice problem. That's really good if you ask me. So I'll start off with this corner right here. This is the longest carbon chain. I do have multiple places of entry. I could have started counting here, 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 here. But just because of logic, I'm yielding on this side. Another reason why I justified starting counting here first is because I get an instant branch on 4 instead of getting a branch all the way here at 6. This one depends on your professor. This question is asking for strictly IUPAC. So I will just keep it IUPAC. I won't use any common names throughout this video. So just kind of move something on my screen here. I got it. Automatically, I've seen my substituents right here. I see a methyl, I see a methyl, and then I see a complex substituent. I see a propyl. Right, this is a propyl with a methyl with a methyl. That's what I see. This is my longest carbon chain. Just color coding it for you guys a bit better than what I did before. If I would write this out, I would write out 4-methyl, and this is 5-methyl. Complex one I will be leaving alone for now. Naming a complex substituent using IUPAC requires, let's just say it's its own little molecule you're naming. It's not hard per se, but you should focus on your smaller substituents and then do your complex later on. For me personally, I think it builds confidence after you get them. This isn't a dash, this is a comma right here. Then there's a dash here, dimethyl. Oh no, no problem. Perfect. Let's move on to our complex substituent. For the complex substituent, I already noticed that it's a propyl group. That's 3. Making this a propyl group, like how I would name the other ones, I would start off with writing the longest carbon chain for this is propyl. And there's a substituent here, which is, let me use another color so you guys don't get confused. Green works. So there's a 1-methyl, and there's another methyl here. Understanding this, I'm able to again combine them like how I did in the beginning. But this is a great example to introduce a complex substituent, which would get me 1,2 dimethyl. Dimethyl propyl. Now, what makes this different than a complex substituent is that I'm branching out. So this is a 6-1-2 dimethylpropyl because I'm coming off from the 6th carbon. Now, how would I connect this, right? I already mentioned that my longest carbon chain for this one was 12. 12 being dodecane. Right? Well, again, I told you that it doesn't matter, but usually it doesn't matter about the abbreviations. You're not looking at the dyes, you're looking at the M's. Both of these are methyl, but this is a methylpropyl, so it just looks better if you start from 4, 5 dimethylpropyl. As I write this, it's sorry, just got some papers here. It's better. As I write this, it's important to mention the only prefix that counts for some awkward reason. Very good to ask your professor why it does. Many of them don't know. Is iso. Isopropyl in a common name will always count in your alphabetical order as you're writing this. But for this case, I'm only asking you for IUPAC. So you can say in these cases it never counts. Dodecane. That's the name of this molecule. Did you guys get that? Hopefully. Let's move on. I want you guys to try this. This is going to be a really fun problem for you guys. It's not that hard. The difficulty of this problem is, in my opinion, more or less than the previous one. Give it a shot. Okay, hopefully you started off by numbering your chain from this direction here. You must be asking me, why didn't I start numbering this chain from here or here? Automatically, if I started numbering from here, I would get a methyl. This would instantly get me this methyl group. Well, again, like I said, first rule, find your longest carbon chain, which is pentane. Second rule, give me the lowest number of the substituent should have the lowest carbon number, which in both of these sides they do. Now this applies to the third rule. Third rule being which one comes first alphabetically. Bromo beats a methyl group. Just go right here. So longest carbon chain, pentane, 2 bromo, 3 bromo. And there is a another 3 bromo. I could combine all these, get 2, 3, 3. Tribromo. Sometimes I feel like I have way more room than I actually do. Tribromo. And I can't forget about my methyl, 4 methyl. So when writing this IUPAC, what will come first? The B or the M? Alphabetically, the B comes first. So I will write it like this. 2, 3, 3 tribromo 4 methyl pentane. It's quite sloppy, but that's a pentane for you. This one's really fun too. Draw the appropriate structure from the following molecule names. Looks scary, but it really isn't. You want to start off, when doing these type of problems, start off with the longest carbon chain, which is hexane. So 1, 2, 6. So if I would number it, 6. Now, as a victory, cross this out. For this example, you can. I'm not sure if you should on your exam, but I don't see it being a big deal. 2, 2, 4, 4 trimethyl. Well, let me do this in another color. I'm doing methyl, so why not keep it green? So 2, there's a methyl group here. There's a methyl group here. There's 2 methyls on 4 as well. Now I can cross this out. Tetramethyl. 2, 2, 4, 4 tetramethyl. Perfect. Now it says on 3 there's a complex substituent. I should have drawn this here. It's fine. I'll try to fit in an ethyl group. There you go. And on ethyl, which is my longest complex substituent, there's 1 methyl group coming off of it. Oops, wrong thing. Perfect. This is how you draw this molecule. This molecule isn't very... This molecule, for your exams, it's not, what's the word? Cute enough. Yeah. Cute enough practically means you want to draw your molecules that are fitting bond angle. So if I would draw this fitting bond angle, right now all of these do, but instead of drawing it like this, I could just draw this molecule. I thought I selected black here. Oh, I see. I could draw this molecule like this. Right? This is more fitting bond angle. Got it? Let's move on. Let me erase this molecule. Hopefully you guys got that. And make sure to always make your organic molecules cute for your professor. Or in life generally. Fun fact is that many of the problems you get aren't cute. This molecule right here is not cute. If you draw this for your professor all bending and stuff, he might be not happy. He might say, oh, you're breaking, you're not adhering to bond line. You would want all of this to be straight. The only reason they do it, that there's a curve here, only reason it's curving here is to throw students off. Or, yeah, so the professor would never draw it like this on an exam, but they might give you something like this to name. So I think that's quite funny and organic. Let's move on. So we have a nonane molecule. Nonane is 9 carbons long. So 1, 2, 3, 4, 5, 6, 7, 8. 9. I want you guys to pause this video and try to solve it for yourself. Trust me, this one you will have a blast with. So 2, 2. Let me just start by numbering my chain. The numbering part isn't required. It just helps me, and I think it'll help a lot of students. So you have 1 and 4. These are fluorines. Some professors would require you to or suggest that you draw the electron groups on these fluorines, and to make it octet friendly, which is the choice of your professor, and it could help in later chapters. So if you want, you can do that, but just for this video I am not gonna do that because it's already can get very sloppy. I'll do it for one of these. So this is how you would draw it. Good. Let's cross this out. Now comes our complex substituent, propyl. Remember, propyl being the largest. And propyl is starting on the 5th carbon, as you can see. Propyl. Boom. Ignore my propyl being really long, but it's just the way it is, I guess. So I've drawn my propyl. There's on my propyl, on the 1, 2, 3, there is a methyl group coming off of my propyl on 1. And there is another methyl group coming off of my propyl here. So, like that. Perfect. You can see it's perfectly octet friendly. At the propyl, I have one coming off here, the other one coming off here, meeting this requirement, and it's all on the 5th carbon. I've successfully named this molecule. That was lingering. Perfect. Identify the primary, secondary, tertiary, quaternary carbons atoms in 2,2-dimethylbutane. This is an example of a problem you might get on an exam. On an exam, it might give you a molecule name and you have to draw it to do other things with it. Rather, that's bromination, which you'll learn in future chapters, or it's chlorine, or if it's just identifying something on the molecule. The professor might just give you a huge molecule and be like, hey, how many functional groups are there? What are the common names? Whatever the case is. You will, again, great practice. This is a great confidence booster if you ask me. Give it a shot yourself right now. Hopefully you paused the video and gave it a shot. I'm going to try now to name it again. Same rule, start with butane. 1, 2, 3, 4. Perfect. It's saying it's branching off 2 methyl groups on carbon 2. Boom, boom, methyl groups. And it is saying, now it is stating to identify the primary, secondary, tertiary, quaternary carbons. This literally means how many carbons are bonded to another carbon. This is very different from hybridization, which you've learned in chapter 1. In hybridization, you're often looking at bond sites, right? You see if something has 4 bond sites, subtract 1, sp3. That's usually a general rule of thumb. But in order to identify what type of degrees these carbon have, I have to identify what type of bonds do they have. For example, my first carbon is bonded to only 1 carbon. My second carbon is bonded to 4 carbons. First carbon, 2 carbons, and 1 first carbon. That's the answer. Now, I did say I would teach you guys, check it. Perfect, good. Hopefully you guys got that. I did tell you I would teach you guys, or show you guys all of the abbreviations that you have to remember to do nomenclature. I'm going to do that now. If you already know it, feel free to end the video now. If you don't, stick around. It's good practice. So if you have one carbon, there are possibilities you can get. I'll go all the way up to 20. So yeah, 18, 19, 20. You can start off with a methane. This is just naming your longest substituent. So I'm just gonna put ane here just because it makes sense. I just don't want to stop it with meth. You have ethane. You have propane. You have butane. You have pentane, hexane, heptane, octane, nonane, decane, undecane, meaning 1 plus 2, dodecane, which we used above, meaning 2 plus 10, 12, tridecane, 3 plus 10, tetradecane, and it becomes really easier after that. Pentadecane, hexadecane, heptadecane. Oops, just fix this right here. Perfect. Octadecane, nonane, and the real weird one, if you ask me, is icosane. Pretty weird, right? So automatically, I'll give you guys a way to remember this. But you'll notice that 5 through 19 are pretty basic to memorize, but this one right here often throws students off. What? There you go. So this one, there are abbreviations you have to memorize. Un, do, tres is pretty fun to memorize. I always memorize it like, kind of like a language, like. And it's not the French 1, 2, 3. I know that, but to me it just works. And the last one is icosane. These are all you have to memorize in order to name your substituent.